Let's now look at a few exam questions regarding this first lesson on Chapter 5. The first is this one, Paper 7, June 2008, Question 5. And it says this: when a guitar is played regularly, a string breaks on average once every 15 months. Broken strings occur at random times and independently of each other. Show that the mean number of broken strings in a 5-year period is 4. Okay, this is a clear indication that you have to use the Poisson distribution. But anyway, for this question, one only. If X is the number of strings broken in a 5-year period, how do you calculate that? It's going to be 5 times 12, that gives you the total number of months. And so the expectation of X, which is equal to NP, is going to be 60 times the probability, which is 1 over 15, which gives you 4. Then on question 2, a guitar is fitted with a new type of string which, it is claimed, breaks less frequently. The number of broken strings of the new type has noted after a period of 5 years. The mean number of broken strings of the new type in a 5-year period is denoted by lambda. Find the rejection region for a test at the 10% significance level when the null hypothesis, lambda equals 4, is tested against the alternative hypothesis of lambda smaller than 4. Okay, so let's put all the information here. The null hypothesis, lambda equals 4. The alternative hypothesis, lambda is smaller than 4. The significance level of the test, that is 10%. So again, we are going to use the Poisson distribution, and we are going to start calculating the probability that X equals 0, 1, 2, etc. until it goes above the 10% threshold of the significance level. So here you have, okay, here you have the running total. The probability that X equals 1 is this, add to that 1, etc. Well, you already know how to do this. Right now, this is at 9.1%. For X smaller or equal to 2, you have 21.8%, already above the 10% threshold. So the rejection region corresponds to the value X smaller or equal to 1. Then question 3, hence calculate the probability of making a type 1 error. The probability of a type 1 error is the significance level of the test. So we have calculated here already. It's 0.0916. Then you have extra information. The number of broken guitar strings of the new type in a 5-year period was in fact 1. State with a reason whether this is evidence at the 10% significance level that guitar strings of the new type breaks less frequently. So X equals 1 is within the rejection region, right? Falls within the rejection region for a 10% significance level. And this means that there is evidence that the new guitar strings break less frequently. Okay? As you can see here, the type of question is similar to the ones that you saw on the previous chapter. You are just going to use the Poisson distribution instead of the binomial distribution. The next question is a paper 7 from winter 2006, and it's question 6. It says, pieces of metal discovered by people using metal detectors are found randomly in fields in a certain area at an average rate of 0.8 pieces per hectare. People using metal detectors in this area have a theory that plowing the fields increases the average number of pieces of metal found per hectare. After plowing, they tested this theory and found that a randomly chosen field of area 3 hectares yielded 5 pieces of metal. Carry out a test at the 10% significance level. Okay, so let's put the information here first. Let's go to that question. Okay. If X corresponds to the number of pieces of metal found in a 3-hectare area field, then we are going to multiply, let me go there again, the number of pieces per hectare times 3, which is the size or the area of the field, which gives you a value of 2.4. So we are going to test X equals 5 at a 10% significance level. The null hypothesis is that lambda equals 2.4, and the alternative hypothesis is that after plowing, the number of pieces of metal found increases. This corresponds to lambda being bigger than 2.4. So let's do the test and start calculating probabilities from X equals 0 until eventually it gets bigger than 10%. Sorry, smaller than 10%. So here you have the values. This is the running total. This is 1 minus p. And as you can see here, this is the point where the percentage gets smaller than 10. Okay? And it corresponds to the rejection region. It happens when X is bigger or equal to 5. As X equals 5, it falls inside the rejection region for a 10% significance level. So this means that the null hypothesis is rejected, and the alternative hypothesis that plowing the field increases the average number of pieces of metal found per hectare will prevail. Next question. Where am I? What would your conclusion have been if you had tested at the 5% significance level instead? Okay, at the 5% significance level, X equals 5 would be too small a value to reject H0. Right now, at the 10% is right at the limit, as you can see. Okay, the rejection region is X bigger or equal to 5. So if you decrease the significance level, this would obviously be would not be in the rejection region, which means that you would not be able to reject the null hypothesis. Then Jack decides that he will reject the null hypothesis that the average number is 0.8 pieces per hectare if he finds 4 or more pieces of metal in another plotted field of area 3 hectares. If the true mean after plowing is 1.4 pieces of metal per hectare, calculate the probability that Jack makes a type 2 error. For a type 2, as you can see here, the circumstances have changed. Okay, so you are going to use this new data to calculate the probability of a type 2 error. As you can see here, the value of lambda has changed. Okay, the number of pieces found per hectare is no longer 0.8, is 1.4. So you have 4.2 pieces in every 3-hectare area. And the probability of the type 2 error is what? This happens when H0 is accepted, or you fail to reject H0, to be more precise, although it is false. If Jack rejects H0 when X is bigger than 4, then he will accept it if X is smaller than 4. So the probability of a type 2 error is that 4. Therefore, the probability that X is smaller than 4 for the new lambda, 4.2. So here you have the calculation, and this is it. Last one. It's Spring 2010, paper 71, question 10. A hospital patient's white blood cell count has a Poisson distribution. Before undergoing treatment, the patient had the mean white blood cell count of 5.2. After the treatment, a random measurement of the patient's white blood cell count is made and is used to test at a 10% significance level whether the mean white blood cell count has decreased. Question 1. State what is meant by a type 1 error in the context of this question, and find the probability that the test results in a type 1 error. Again, what is a type 1 error? A type 1 error occurs when a null hypothesis is rejected when it is in fact true. In the context of this question, a type 1 error occurs when the test shows that the average count of white blood cells on that patient is considered to have decreased when in fact haven't. Okay? What is the actual probability? If X is the number of white blood cells on a patient, let's start making the calculation until we get a value that is bigger than 10%. And this happens when this happens over here. So the significance level of the test is this over here, 0.0342, the one that doesn't go over the 10%. And this is also the probability that the test results in a type 1 error. Again, the probability of a type 1 error is the significance level of the test, which is this one. Given that the measured value of the white blood cell count after the treatment is 2, carry out the test. So if it is 2, and if the rejection region is when X is smaller than 2, 2 is already out of the rejection region. Okay? This means that there is not enough evidence to suggest that the average count of white blood cells have decreased. Last one, find the probability of a type 2 error if the mean white blood cell count after the treatment is actually 4.1. So here you have the new piece of information that will allow you to calculate the type 2 error, the new lambda. Type 2 errors occur when the null hypothesis is accepted when it is in fact false. In the context of this question, a type 2 error occurs if X is bigger or equal to 2. Okay? Don't forget, the rejection region is when X is smaller than 2. So here is the acceptance region. Okay? So we are going to calculate the probability of a type 2 error by doing this. Okay? So 1 minus the probability that X equals 2. Don't forget, you are going to use the new lambda. That's what I did over here. And there you have it, the probability of a type 2 error.